is this is 1 meter. Okay, so when this thing falls, we want V to be constant. Does that make sense? And if we want V to be constant, once again, what must the sum of the forces be? 0. Sum of the forces must be 0. Right? So once again, we're saying FB minus FG equals 0, or FB is equal to mg. Okay? Oh, whoops. I'm sorry. Do you see my... Yeah. And then, jeez. And then I said the magnetic field from part 1, right? So our field's like this. So ultimately, we know the current's going to go the same way, the induced current. So then here, again, I go BIL equals mg. Now the question is, what is I? And then once again, I go back to this same statement, right? And so I is EMF over R. Now, here's where EMF comes into play, right? And what is EMF? EMF is equal to negative, well, I'm not going to worry about the negative, delta phi over delta t. It is the change in the flux over the change in time. And let's take a look at that. Flux is B. Does the B change as it falls? No, it doesn't, right? So B is the same. And so it's going to be delta A over delta T. And how does A change? Well, what is A? What is the area of this? What is the area of that rectangle? Let's not use the 1. Let's just say in general, it's L times H. Doesn't that make sense?
Yeah.
Which one changes, L or H?
H.
Do you see that L does not change? So what we get is BL delta H over delta T. What do you call delta H over delta T? Do the meters. Do the unit analysis. Meters. I'm such an idiot. Do the unit analysis. H is in, T is in. What do you call? Velocity. So this becomes BLV.
Could you have used the other one? Isn't it like
QVB sine? Well, you don't know how much charge is in it. You could do it that way. Then you just have to say. Then you have to do like, okay, a charge is like one particle. One particle is 1.6 times 10 to the minus 19 coulombs. You get what I'm saying? And then work it that way. You could. Okay, so from this, right, I get I is equal to BLV over R. Let's go back over here and plug it in. So I get B times I, which is BLV. I'm doing a tail on this, so that's velocity over R times L equals mg. What are we looking for? Velocity? Okay. So then I get V is equal to mgr over B squared L squared. Ta. Thank you, come again.
Can you go back to where you have the change in the flux?